Assalamualaikum and hi everybody. In this video I will teach you how to use the exact equation to solve the first order differential equation. So in order to solve the first order differential equation by using the exact equation method, first we must have a general form of exact equation. So the general form of exact equation is in this form, where you can write the differential equation in terms of function mxy multiply the derivative dx plus a function nxy dy, and then this differential equation equal to 0. So this equation, the differential equation, is called the exact equation if it fulfills this particular condition. So in order for this equation to be called exact equation, it must have this condition, where if you take the partial derivative of function m with respect to y, this is just equal with the partial derivative of this function n with respect to dx. We call this is test for exactness. If we find out that del m over del y equal to del n over del x, then this equation is exact equation. So if this is exact equation, we can solve it by using this method. Right, step number two. So the solution for exact equation, so this is the exact equation, so the solution is just a function fxy equal to constant c. So in order this function to be defined as this, so you need to find the function fxy. So to find the function fxy from the exact equation, you can take it from either m or either n function. So in this solution, I will use the function m. So let's take a function m. So fxy, which is the solution, are equal to integration of function m with their respective dx plus unknown function ay. So this solution is defined as this one, integration of function m with respect to dx plus unknown function ay. So after you find the integration, you need to differentiate back with respect to y. Remember, you integrate with respect to dx, integrate with respect to dx, and then in the next step, this function you differentiate back with respect to y, integrate with dx, differentiate with respect to y. So when you differentiate this one with respect to y, that means you will get a function of this one. So differentiate the answer in 3 with respect to y and equal to nx. And of course, when you differentiate with respect to y, this ay, where this is a function in terms of y, when we differentiate with y, you will get a prime y. So when you equate to nx, so you need to find what is a prime y. So after you have find the ay, then you need to find back what is ay by integrating this function with respect to y. So this is step number 4. Find ay by integrating a prime y with respect to y, and then substitute the answer in this answer in 3 and simplify. So if given condition, find the constant of integration c and the particular solution. And let's solve the next example by using exact equation. And let's see this one, y 2xy dx plus x squared minus 1 dy equal to 0. So this one is already in general form. So let's say this is function m, this is function n. Remember that the function m, the derivative is dx, the function and the derivative is dy. So let's rewrite this function m. So we have m is 2xy, the function n is x squared minus 1. So test for exactness. So del m over del y. So differentiate this with respect to y only. So partial differentiate. So we have 2x. So when we differentiate with respect to y only, that means the other variable we treat as constant. So here actually this is variable x, but because we differentiate with respect to y, we treat it as a constant, just like the number 2. So when we differentiate, so the constant you will get as 2x. The next function n, so differentiate with respect to x, so del n over del x. So here we have x squared, so differentiate with respect to x, so we get 2x. Minus 1 is constant, so when we differentiate we get 0. So now we observe that our del m over del y are equal to del n over del x. So our conclusion, this is exact equation. So because this is exact equation, now we can solve it by using exact equation method. Right, to solve it by using exact equation method, first the solution is fxy equal to a scalar, function c, scalar c, constant c, fxy equal to c. Alright, in order to find fxy, we can integrate a function m with their derivative dx plus a function ay, which is to be find later. So integrations of m with respect to x, so we have 2xy dx plus ay. When we integrate with respect to x, that means y just a constant. So we have 2x squared y divided by 2 plus ay. So we have x squared y plus ay. So this function, then we need to differentiate with respect to y. First we integrate with x, then differentiate with respect to y. So df over dy equal to x squared plus ay, a prime y, and equate this with n. So our n is x squared minus 1. So now we observe that here we have x squared, here we have x squared. That means a prime y is negative 1. So a prime y is negative 1. So what is our ay? Ay is integrate of this function with respect to y. So we get negative y. So actually we came this one, we have a constant c. Let's say this is equal to c1. But the constant of integration, you don't need to put this one because lastly you will carry out to the right hand side. So the answer is, so we know that ay is negative y plus c1. So substitute into this function fxy. Fxy equal to x squared y plus negative y plus c1, and this is equal to c. So we can rewrite this one as x squared y minus y plus c1 equal to c. Hence combine all the constant together. So x squared y minus y equal to a, where a is c minus c1. Oh, this is the final answer. Alright, Let's see example number 10. Find the solutions of 3x squared y plus exponent y dx plus x cubed plus x xy x exponent y minus 2y dy equal to 0. So let's say this is function m, this is function n, m is dx and with dy. Alright, let's test for the exactness. So m equal to 3 x squared y plus exponent y, while n equal to x cubed plus x exponent y minus 2y. So del m over del y. So del m over del y. So here we have 3x squared plus exponent y. And for n, del n over del x. So here we have 3x squared plus exponent y plus 0. So here we found that del m over del y is equal to del n over del x. So the conclusion is this is exact equation. So because this is exact equation, we can solve this equation by using the exact equation method. Alright, so let's remember how to solve the exact equation. So first, the solution will be fxy equal to c, where the function fxy we can integrate directly from m dx plus ay, function ay. So what is our m? So m is integration of 3x squared y plus exponent y integrate with respect to x plus ay. Alright, so when we integrate with respect to x, so here we have 3x cubed y over 3 plus x exponent y. Remember that any variable except x is the constant. So here this one is a constant. Treat this as a constant. For example, just a number. So when we integrate a number, you put x. And here a function ay. So the answer will be fxy equal to x cubed y plus x exponent y plus ay. Let's check again. X cubed y plus x exponent y plus ay. Alright. And then find the derivative of f with respect to y. First we integrate with respect to x, then differentiate with respect to y. So when we differentiate with respect to y, here we have x cubed plus x exponent y plus a prime y, and this is equal to the function n, where the function n is x cubed plus x exponent y equal to 2y. X cubed plus x exponent y minus 2y Okay, so from here we have x here, so x minus x cubed 0, x plus x exponent y, x exponent y minus x exponent y 0. So a prime y equal to minus 2y. A prime y equal to minus 2y. So ay equal to integrations of minus 2y with respect to y. So we get minus 2y square over 2, which is equal to minus y square. So substitute this one ay here into the solution. So remember that our solution is fxy equal to c. So fxy equal to x cubed y plus x exponent y plus ay minus y square minus y square. Actually, this came with the constants of integration. For example, let's say this is c1, but I didn't write the c1 here because later on I will bring to the right hand side of the equation. So this one equal to c. So when I bring to the right hand side of the equation, c minus c1, so let's say this is another constant. Let's put just constant c. So this is my answer. Since the initial condition are not given, the condition is not given, we cannot find the value for C. Example 11. So this one came out with the initial condition when x equal to 0, y equal to 2. Solve dy over dx equal to xy square minus cos x sin x over y 1 minus x square. Right, so first let's rewrite this one or reform this equation so that it represents the exact equation standard form. So exact equation standard form where you have mxy dx minus nxy dy equal to 0. So let's cross multiply. Dy multiply by this one, dx multiply by this one, and then rearrange so that we can have, first we have y 1 minus x square dy equal to xy square minus cos x sin x dx, and then rearrange so that we can have x y square minus cos x sin x dx minus y 1 minus x square dy equal to 0. So we must have an equation where this equation equal to 0. Alright, so from here we have our function m. M is xy square minus cos x sin x, and function n is express this one as negative y plus y x square, and then m differentiate with respect to y, so del m over del y. So differentiate this one, we have 2xy. Differentiate n, so here will be 0 because this is cos x sin x when we differentiate with respect to y. So here this term no y variable, this one will be 0. Differentiate n with respect to x, so del n over del x. So the first term negative y, no x will be 0. Here we have 2xy, which is del m over del y is equal to del n over del x. So this is exact equation. This implies this is exact equation. Alright, so because this is exact equation, hence we can solve it by using the exact equation method. So for exact equation method, the solution we find is fxy equal to c, where fxy equal to integration of m dx plus some function ay. So m, integrate this with respect to m. Our m is xy square minus cos x sin x, xy square minus cos x sin x. Integrate with respect to x plus function ay. Alright, so to integrate this one, there are two parts. First part is integrate xy square, and second part is this function. So to integrate this function, let's focus on the second function first, because first function is easy when you integrate with x. So you have x square y square over 2, x square y square over 2, and this one is quite complicated, so let's focus on this one first. So how we are going to find the integrations of negative cos x sin x? Integration negative cos x sin x dx. First, let's move the negative to the side before the integration sign. So we have cos x sin x dx. Alright, now let's see these facts. If we have cos x, if we differentiate cos, we get negative sine. So let's say if I have u equal to cos x, if I differentiate u with respect to x, so I have du over dx, I will get negative sine x. And then I found that here we have sine x dx, so why not this dx here I put here? So I will have du equal to negative sine x dx. Now I can replace or substitute u and du, substitute this one u and du into this equation. So I have negative cos x, cos x is u, sin x dx, sin x dx is negative du. This one, because this is positive, so negative will be negative du. So negative du. So this one will be negative and negative positive, so integration of u du. This one will be u squared over 2, where u is cos x, so cos x squared, so cos square x over 2. Right, now I have the solution for integrations of negative cos x sin x, which is positive cos squared x over 2. Right, so I can use this one, this solution, into this one. Alright, so integration of x y squared with respect to x, so I have x squared y squared over 2, negative cos x sin x, this is positive cos square x with over 2, and plus ay. Alright, so this is our answer. Next, differentiate the function partial differentiate f with respect to y. So del f over del y. Del f over del y. So now everything that has x is a constant. So here we have 2y, 2x squared y over 2. This one is 0, so plus a prime y. This one should be equal to n. So what is our n here? Where is our n? This is n. Negative y plus y x squared equal to negative y plus x squared y. So this one, 2 divided by 2, x square y and x square y will cancel everything, so a prime y will be negative y. So what is our ay? Integrate negative y with respect to dy. So this one should be, let me erase this one, clear page. So integration of negative y with respect to dy, so negative y squared over 2. Right, so let's write the final answer. Fxy equal to c fxy. So fxy, what is our fxy? So this is our fxy. X square y square over 2 plus cos square x over 2 plus ay. Ay, we know that negative y squared over 2. So x square y square over 2 plus cos square x over 2 minus y square over 2. And then don't forget, because this is equal to c, and we also have a condition where the condition given as when x0 y equal to 2. So when x equal to 0 y equal to 2. So to find the constant c, so c equal to x0 y equal to 2 square over 2 plus cos squared 0 over 2 minus 2 squared over 2. So this one will be 0. Cos squared is 1, so 1 over 2. Cos squared 0 is 1, so 1 over 2. So 4 divided by 2 equal to, sorry, this is minus 4 divided by 2 is 2, so 2 minus 1 over 2, this is equal to negative 3 over 2. So our final answer will be negative 3 over 2 equal to x square y square over 2 plus cos squares over x, cos square x over 2, sorry, minus y squared over 2. Alright, so this is our answer. Because everything is divided by 2, actually you can simplify it by, because everything here is because everything is over 2, you can multiply it by 2. So you can rewrite this one as negative 3 okay, so this is negative 3 x square y square plus cos square x minus y squared. So this is final answer. Alright, so finish the exact equation. With that, thank you.